choose new domain in the analyze options. Click OK. Click Generate Mesh. Select default device and then start. Select Analyze Sports and choose Full Field Pack Work. Select the material. Polyflow RIPP 3625 CS1. Ensure the manufacturer is a Suchman GmbH. Click Detail to verify that it installing PP. Temperature. For the temperature we are using on surface temperature of 60 degrees Celsius and mute temperature of 200 degrees. The recommended range is 40 to 80 degrees for the model and 180 to 220 degrees for the mute. And the absolute maximum new temperature is kept at 230 degrees and the part will be ejected at 110 degrees. Lastly, the limit for maximum shear stress and shear rate are 0.25 MPa and 100,000 seconds. Respectively. And the transition temperature for the multi-shot is 122 degrees. The specifically volume change. The data essential for it. It helps a current collect volume sharing page and work page. The default model used here is the two-domain field model. Next up is the mechanical properties tab. The key are set the number of channels to 12. Set the distance between channel center to 30 mm. Set the extension beyond the part to 200 mm. Review the preview and click finish. Next, set the tube outline. Assign tube for an outline.
可以快点吗？
好。First, let's do the fill time. The simulation showed that the cavity fills complete in 1.962 seconds. The flow pattern is well balanced in the middle, reaches its extremes of the part at the exact same time, which helps minimize voltage. Next is the pressure at VP switch over. The maximum pressure required is 21.97 MPa. This is a relative low pressure and well within the maintenance limits, indicating we will not face any short issue due to pressure concentrates. Looking the temperature at flow front, the results are highly stable. The temperature range highly between 199 and 200 degrees Celsius. This uniform temperature prevents flow lag and ensures a good surface finish. degradation limit, so we don't need to worry about martial burning or property loss. The sign shows the bulk temperature at the 30-second mark. The highest temperature is 202.4 degrees Celsius, mainly concentrated in the deeper section and near the gate. There are the hot spots we need to pay attention to for the cooling optimization. Here we have the time to reach rejection temperature, the maximum boiling record is 70.5 seconds as expected. The deeper base hydration dictated the overall cooling cycle. If we want to reduce cycle time, we must improve the cooling efficiency in these specific areas. Looking at the ozone layer fraction at the 30-second, the red area show a fraction of 1, meaning they are completely solid. However, you can see some green and yellow spots in the deeper region, indicating the center of the melt and is still entirely liquid at the time. This is critical result. Volumetric shortage and injection, the maximum shortage is 7.24%. You can observe that the higher shortage value correspond to the deeper section. We should monitor the area closely to prevent thin marks. The XY plot shows the pressure at the injection location over time. We can see steady pressure build up during filling, peaking at around 42 MPa during the packing phase, and then holding steady. The profile dropping to roughly 185 degrees at the extremity. The mute has not lost too much heat during viewing, which is except for the upcoming packing phase. Now let's address potential modeling defects. Start with air traps. The simulation highly served dots where air might be trapped as flow from coverage. We will need to ensure proper venting is meshed into the mold at this specific location. Particularly along the parting line and deep ribs. The plot indicates the sigma index. The maximum value is roughly 0.91%. The highest risk shown in green and yellow are located at the beaker base area and outside to structure right. We can mitigate this by whitening our packing profile and extending the cooling time if necessary. First, forward to 30 seconds into the cycle, looking at the pressure distribution. We observe that the pressure inside the cavity has decayed satisfactorily as the part cools and solid fuels, dropping from the packing pressure down to near zero level in most areas. Let's review the sigma index. The maximum index value remain at approximately 0.91. The pulse acts as a relative risk map, clearly highlighting the thicker base protrusion and drives